We have seen technology continue to modernize by each new generation, from gas vehicles to electric vehicles and from landlines to smartphones. However, one thing that we tend to overlook is the modernization of the pencil, a universal tool that has been used since the Stone Age with stone and wood. As we already know, most pencils use lead or graphite as a way to write on a sheet of paper. But because of the technological advancements that we have made towards the pencil, a stylus, or in this case I will be focusing more on the Apple Pencil, uses a capacitor tip that sends signals to your touchscreen, which is how it is able to detect where you are writing or drawing. However, in order to understand how the Apple Pencil works, we must first understand how touchscreens function. There are two types of touchscreens, one being a resistive system, which is what most ATMs and payment terminals use, and the other one being a capacitive system, which is what most tablets use and the one I will be discussing. iPhones and tablets use a type of capacitive system known as a mutual capacitance, as well as a self-capacitance to allow the user to use more than one finger on the screen. This will avoid the system from becoming overwhelmed. Capacitive system works in a grid using both driving lines and sensing lines. A driving line provides current for the touchscreen, whereas a sensing line detects when a finger or stylus touches the screen and is able to locate where the touch is happening. And because this is a grid system, the entire area of the phone or tablet has its own signal. So when the screen is triggered by a touch, this will send an electrical signal to the device's processor and detect where the touch is coming from and the force of the touch. This is the reason why most gloves are not compatible with touchscreens. Because they are made of cloth, which muffles the electrical charge from our fingers, the device is unable to pick up an electrical signal, thus leading to an unresponsive device. Unless the gloves are made of conductive thread, which gloves that are touchscreen compatible are made of, will your phone work. So next time you find yourself frustrated with having to take off your gloves to use your phone, just buy some copper-fused fingertip gloves. Similarly, there are two types of styluses. One being a capacitive stylus, which are less precise due to its large foam or rubber tip, but does not need to be charged, and the other one being an active stylus, which the Apple Pencil is considered as. This stylus is more advanced, allowing the user to have a more precise experience due to its fine tip and capability to detect pressure sensitivity, angle, and palm detection. This type of stylus, however, does need to be charged. Think of it as the Einsteins of styluses compared to that of a capacitive stylus. Active styluses were created as a way for more precise work against touchscreen devices. In order to work, they would need to emulate a human finger, because as I have mentioned previously, humans are good conductors of electricity. In order to do this, most styluses are made with foam, plastic, or metal, such as aluminum or copper. This is so it would be able to cause an electrostatic disruption to the device and have it respond seamlessly. In the case of an Apple Pencil, just under its plastic conductor tip is an aluminum tip that includes two emitters that it is responsible for detecting the angle and force that I mentioned not too long ago. In order for an active stylus to work, the device that it is being used on needs to have a chip within the device for it to be compatible with the stylus being used. This is most likely the reason why you don't see people using an Apple Pencil with a Samsung Galaxy tablet. So how does the Apple Pencil work on an iPad? In order to figure this out, we first have to learn how both devices work individually. And since we have an understanding on how an Apple Pencil works on an iPad, let's jump right into it. So we know that the iPad is a capacitive system type due to the fact that it does not rely on pressure for the flow of energy to work, but rather it relies on an electric conductor such as a human finger, or in this case the Apple Pencil. As for the pencil, we know it to be an active stylus because I have mentioned it before in a previous slide, but also because the Apple Pencil is known for its precise technology, as they even mention it in their advertisements.
This began by re-engineering the touch subsystem of the display to measure both finger and stylus input on the same plane with optimal accuracy. When you're using the pencil, the system scans twice as often, allowing iPad Pro to capture more points in a single stroke. Highly responsive sensors built into the tip of Apple Pencil work with the iPad Pro display to detect position, force, and tilt.
How these two devices go hand in hand is all in the power of technology. With the iPad screen relying on an electrical charge in order for it to respond, the Apple Pencil would need to have a type of conductor. This conductor would be the tip of the pencil because the material is made of a plastic conductor. This plastic conductor would emulate the same way our human fingers conduct an electrical charge. So when it comes in contact with a capacitive system screen, thanks to the system being in a grid of rows and columns, the touch of a finger and or stylus will be detected in any inch of the screen and would then be processed within 1 nanosecond or 1/1,000,000,000 of a second. What happens within this time frame is that there is a voltage drop from that touch point on the screen, causing whatever is written, drawn, or tapped to be detected.